I'm a big YouTuber. These we have already talked about those. They will be on the identities quiz. These will be on the identities quiz. These are new. So whenever we were like building the unit circle, oh gosh, I gotta get mine. We talked about taking, like a point here. That point was X, Y, which meant that this side was X and this side was Y. And what was the radius? If this is the unit circle, is 1, right? So it would be true here that this would be a right triangle. It would be true, of course, that X squared plus Y squared equals 1 squared, correct? What did our X stand for on our unit circle? Like at the top, X is cosine. So that means cosine of theta squared plus what did the Y stand for? Sine of theta squared would have to equal 1. And that is our Pythagorean identity. So that's where it comes from. Sine squared plus cosine squared equals 1. Yeah, you can put cosine first if you want. Typically, you're just going to see it written this way most of the time, but since it's addition, you can write either one first. So the other two here look harder to memorize, but let me show you a trick for this. Usually, we're going to use sine squared plus cosine squared equals 1 a lot. Usually, kids, by the time we do enough problems, don't even have to work to memorize that because we've used it so much that they remember it. But these other two, most of the time, we don't use them as much, and they're harder to remember. But they're not actually different formulas. So, imagine that I did this. Imagine I divided by cosine squared all of these. If I divide all these by cosine squared, right? What would sine squared over cosine squared give me? Tangent squared. What would cosine squared over cosine squared give me? 1. And what is 1 over cosine squared? Secant, right? So if I take my original and divide everything by cosine squared, it gives me the tangent squared formula, right? Same thing would be true. Let me switch colors here. Let's start with sine squared theta plus cosine squared theta equals 1 again. What if instead of dividing by cosine, I divide by sine? If I divide by sine squared theta here and sine squared theta here and sine squared theta here. What is sine squared divided by sine squared? 1. That's this, right? Cosine squared divided by sine squared, cotangent, and 1 over sine squared is cosecant, right? So, I need you to know those other two, but sometimes I have to stop and take the one I know, sine squared plus cosine squared equals 1, and try to remember how to get it for that. So you can do that over to the side if you need to on your quiz to get the other two for that. That's also, I've had students ask me why is it tangent squared plus 1 here and it's 1 plus cotangent here? That's the reason that they wrote it that way, is because they're deriving it from this formula. Does it matter whether I do tangent squared theta plus 1 or 1 plus tangent squared theta? It does not, because it's addition. I can switch the order. It doesn't matter whether the one is first or last here. So you could do it either way, but that's the reason that they're in that order. Okay. So these have to be memorized. We are going to use them a lot in the trig stuff that we do. They'll show back up some in calculus. Like I said, it's not that you got to be an expert, but you will see them again for that. Okay. So let's look at what types of problems we're going to see for this. All right, so we have here that the function f is defined by f of x equals sine squared x plus 1, and the function g is defined by g of x equals 3x minus cosine squared x. What is the x-coordinate of the point of intersection of f and g? So if we're looking for a point of intersection of two functions, what do we have to do?
Get the x.
Yes, but before we do that, what do we have to do? So them equal. So I'm going to have sine squared x plus 1 equals 3x minus cosine squared x. Now, this originally looks terrible because I've got a sine squared and a cosine squared, and I've got this just regular x over here. However, if I think of those identities that we just talked about, what would happen if I took this cosine squared and I added it over here so that I got sine squared plus cosine squared plus 1 equals 3x? What was sine squared plus cosine squared? Oh, I should, when I write it, need your x right there. What is sine squared x plus cosine squared x equal to? It's just equal to 1. So I can replace it with 1. So 1 plus 1 equals 3x. Now we're down to a very easy problem to solve, right? 2 equals 3x. Divide by 3. And x is going to equal 2/3 for that problem. It does. It starts off being very difficult. But if you can find a chance to put a sine squared plus cosine squared, you can just replace it with 1 for that. So, and then once that happens, in this particular case, all of your other sines and cosines are gone, and you just have a simple equation to solve. Okay, so some of these will be in the form of solving equations. So some of this stuff, we've been solving equations, but I haven't given you anything yet where you had a sine and a cosine in it, right? Everything was either all sines or all cosines. You might now get some where you've got sines and cosines, and we'll have to work with those. All right, let's look at another type of problem that you'll have. Okay, this says the function f is given by f of x equals cosecant x over secant x. Write the function f as an expression involving only tangent and no other trigonometric functions. Okay, so we've got to, basically it's asking us to simplify this or rewrite in a different way. So we have to think about some strategies that we can use. First of all, the Pythagorean identities are all for, if we think back to those real quick, the Pythagorean identities here are all sine squareds, tangent squareds, secant squareds, cotangent squareds, everything squared except for the 1s, right? And really the 1s could even be squared because 1 squared is 1. Everything squared, it does not work if it's not squared. So like, for example, tangent squared plus 1 equals secant squared, but tangent theta plus 1 does not equal just regular secant of theta, right? Has to be squared for it to work, because think about what Pythagorean theorem is. It's a squared plus b squared equals c squared. It's not a plus b equals c. You have to have the squares, right? So we cannot do this. So Pythagorean identities are not going to help us out on this problem because we don't have any squares right here, or at least not yet. There's a chance it could come up, but it's not going to help us out right now. So we're probably going to need to use reciprocal identities. And a really good strategy is trying to change everything to just sines and cosines. So for our f of x right here, and when you do this, you need to show your work. You don't just you need to show every step that you do. So I've got cosecant x over secant x. What is the reciprocal identity for cosecant? 1 over sine of x. And what is the reciprocal identity for secant? 1 over cosine x. What do you guys think we could do now? Okay, I can flip it and multiply. So 1 over sine x times cosine x over 1. And that is going to give me cosine x over sine x. What does cosine x over sine x equal? That is cotangent of x. Now, this particular problem, what did it tell me? What's the only thing I could use? Tangent. So cotangent's not tangent. But cotangent is 1 over tangent x. So I could leave the problem like this, and then it would only have tangent in it. Okay, so when we're asked to rewrite only using one type of function or trig function, really you want most of the time, like notice I didn't try to change things to tangent here. I changed everything to sine and cosine, and then when I got to the end, I thought about how I could change it to tangent. So that usually is what you want to do. You want to do all sines and cosines, and then towards the end, it's going to start simplifying into something that you, if it's asking for tangent, you could change the tangent there. All right, so this is not a solving equation. It's just like an equivalent expression that you're looking for there. Any questions here? All right. Okay, here's another example. It says the function f is given by f of x equals secant squared x minus tangent x cotangent x. Which of the following is an equivalent expression for f of x? So, yeah. This has a lot of different ways that we could go with it. We're trying to simplify this. You're not going to be able to just look at it and say, oh yeah, it's that, you know. We're going to have to kind of mess around with it a little bit, which is tricky because if I knew which one I was trying to get to, that would maybe help me a little bit to decide, but I don't know which one of these could be right. I do see this over here, tangent times cotangent. And if I'm thinking about reciprocal identities, those are reciprocals of each other, right? Tangent and cotangent. So I'm thinking of this right here. Let's just leave secant squared x alone for right now because I don't know what to do with that. But cotangent, I got a couple options here. I could do it this way. I could say that this is tangent x, and I could multiply it by cotangent. I could make that 1 over tangent x, right? Because that's our reciprocal identity. And then this tangent is in the numerator, so it's like over 1. What's going to happen with my tangents? They're going to cancel out. And then I'll have secant squared x. I'm still going to have a 1 there because their tangent divided by tangent is 1 for that. Let me just show you a different option on that. Another way you could have done that is tangent could have been sine x over cosine x, and then cotangent could be cosine x over sine x, and then the cosines would cancel and the sines would cancel, and you'd get 1 that way. So a lot of these problems, like Solana and Ethan could do them differently, but they could still both be correct in how they do it. All right, so we got secant squared x minus 1. Is that an answer choice? Almost. We got 1 minus secant squared x, but can I just switch them? No. So I'm almost thinking that's probably not the answer because I can't just switch them, right? So I'm thinking that one's probably out. Okay. Now, secant is squared, and when things are squared, it makes me think of those Pythagorean identities, which you guys don't have memorized yet, but you have the sheet right there. Do you see a secant squared anywhere on those Pythagorean identities? Which one is it? Let's write. Tan squared of theta plus 1 equals secant squared theta. That might help right here, right? So what if we took secant squared x and we replaced it with tangent squared x plus 1? So, and then we'll still have the minus 1 over here. Is that good? So the Pythagorean identity is like a fact. It's true. So that means that we can replace things with this. So if we see secant x, like we've got right here, right? Then secant x is equal to tangent squared x plus 1. So we can take out that tangent squared x plus 1 and put tangent, we can take out the secant squared and put tangent squared x plus 1 instead. A lot like we took our sine squared plus cosine squared on that first problem and replaced it with a 1, right? Because they're equal to each other. All right, so now, though, this is looking good because what's going to happen with that positive 1 and that negative 1? They're going to cancel each other out. What have we got left? Tan squared x. Is that an answer choice? Yes, it is. So C would be our answer for that. There's other ways you can do it, but sometimes doing this 3 or 4 ways makes you more confused than if I just stick with one here. So we're gonna move on. The thing about these problems are lots of them have many ways that you can do the problem. All right, so let's look at 4. 4 asks us to rewrite this expression involving, we're going to rewrite this expression involving tangent and no other trig functions. So I do have a secant squared, which I could change to tangent squared plus 1, just like we just did on the last problem. And that would get a tangent involved here. But I can't do that for the sines and the cosecants, right? I'm not sure about what I should do there. If I were doing this problem, I would change everything to sine and cosine first. So this is what I would do. I would do f of x equals sine of x. Secant squared x is going to be 1 over sine, not sine, what would it be? Cosine. Cosine squared x over, and cosecant, I'm going to make it 1 over sine x. Pythagorean identities must be squared and only work if they're squared. The reciprocal identities can still work, even if you have, like, they're originally not squared, but they work if something is squared to the 3rd power, 4th power, 5th power, any power. You just have to put the squares in both places there. So let's do this. This sign is over 1 right here. So let's put the numerator together. That's going to be sine of x over cosine squared x. And in the bottom, we just still have 1 over sine x.
The one's canceled, right?
What happened right there is like you're doing sine x times 1, which is just sine x, and then 1 times cosine squared x, which is cosine squared x. Or you can think of them canceling. Either one will be fine there. Okay? What do I do with complex fractions? Dividing fractions? Flip the second and multiply. So sine x over cosine squared x times sine x over 1. And when I multiply those together, what will I get?
Sine squared x over cosine squared.
Okay. Are you starting to feel good about this? Because what is sine squared x over cosine squared x? It is tangent squared x. And now we only have tangent, so that is our answer.
You can leave the square.
Yeah. So when it says an expression involving tangent, it does not mean the answer will be just tangent. It means that you won't have any other trig function. So it could be something like tangent squared minus 1, or tangent over or 1 minus tangent. It could. You just can't have any sines or cosines, secants, cosecants in there. So as soon as you get it to where there are nothing but tangents left, then you can stop for that. Unless it's multiple choice, then make sure it matches the answer choice there. So. Okay, questions? All right. Let's keep going. right, this one is equation. Sorry for the poor quality. I copied and pasted that from an older set of notes that I had done. We got cosine x tangent x equals -1, and we're supposed to solve that for 0 to 2 pi. So, could I do this? Cosine x equals -1, tangent x equals -1. Could I do that? No, I cannot. Why not?
Them multiplied together.
Yeah, those multiplied together equals -1. The only time I can do that is if it's equal to 0. If this was equal to 0, I could do that because 0 times anything equals 0, which means if one of them is 0, the whole thing would be 0, right? So I cannot do this whenever it is any number besides 0. So that won't work. I could try moving everything to one side and factoring, but am I going to be able to factor that with a cosine x tangent x plus 1? You don't have any squares. You don't have anything that's really going to work out there. So what we want to try is to use trig identities here. And cosine is just cosine. What could we change tangent to? Sine over cosine. So if we do that, cosine x times sine x over cosine x is going to equal -1. And this cosine is in the numerator, so it's like it's over 1. What's going to happen? The cosines are going to cancel out. And so sine of x is just going to equal -1. And now we've got something like we were doing before. Where does sine equal -1? At 3 pi over 2. So that would be our answer. Okay, so with equations, you're going to see some things are like things we've already done where you can factor, stuff like we're doing on the warm-up, but sometimes you need to throw in a trig identity because you won't be able to solve it using the methods we had before. All right, here is this the last one? Yeah. Here's our last one. All right, this one is a trig equation. I've got cosine squared x minus cosine x plus 1 equals sine squared x. So, I can't, having cosine squared and sine squared is a problem. Maybe I could change it to 1. Am I going to be able to change that to 1? If I move the cosine over here, I'd have sine squared x minus cosine squared x. Does sine squared x minus cosine squared x equal 1? It does not. It has to be plus, right? And same thing over here. If I have to subtract to move this over here, which means it's going to be cosine squared x minus sine squared x. That's not going to equal 1. So that worked on the first problem. It's not going to work here. So you can kind of see how this can be tricky because it can look similar to something you've seen before, but that strategy not work. So you got to kind of play with it. So the key for this problem is knowing this. So let's do this sort of as a side note over here. We know that sine squared theta plus cosine squared theta equals 1. That is a fact we have been given. If I take sine squared theta and I subtract it from both sides like this, I can say cosine squared theta equals 1 minus sine squared theta. Right here. Would that still be a true statement? Here, it's still true, right? I'm just moving that sign over to the other side. So, you may even want to sort of box this in and put a star next to it. This is like a rearrangement of the Pythagorean identity, and it's very helpful if we need to change things to sine or cosine. It is also going to be true. We can do the same thing if I have sine squared theta plus cosine squared theta equals 1. I could also do the same thing with the cosine squared theta. So sine squared theta equals 1 minus cosine squared theta. This is always true. So this is not me actually solving the problem. This is just me sort of rearranging my Pythagorean identity. So these two things right here, we end up using a lot. And in this case, if this was all sines and cosines, I could probably solve the equation. I'm sorry. If it was all sines or all cosines, I could probably solve the equation. Which one should I try to switch to, sines or cosines? I need to do cosines. Why do I have to do cosines? Not just because there's more.
Because it's x instead of y.
Mm-mm. It is because of this right here. Is this one squared? It is not squared. Pythagorean identities must be squared, right? So I cannot change cosine to 1 minus sine. I can only change sine squared or cosine squared, right? So I am not going to be able to change this. So I could change cosine squared to 1 minus sine squared, but then I'm not going to be able to change this, and I'm still going to have sine and cosine. But if I take over here, if I take the sine squared x, and I'm told right down here that sine squared x is the same as 1 minus cosine squared x. If I take this up here and plug it in, then I will have cosine squared x minus cosine x plus 1 equals 1 minus cosine squared x. Yeah, you can pass it. So, questions there? So, now I've got things that are squared. It probably is going to be best to move everything to one side on this. So I could add that cosine squared x right here, and I could subtract that 1. So this is like 1 cosine squared x plus 1 cosine squared x. That's going to give me 2 cosine squared x. The minus cosine x just stays the same. The 1's cancel here. They also cancel here, so we'll put a 0 right there. And so now we're getting down to what looks like the equations we were already solving. What should I do from this point? Factor, and how am I going to factor this one? Bring a cosine out. So I'll have cosine x times 2 cosine x minus 1 equals 0. I will set each one of these equal to 0. Over here I'll get 2 cosine x equals 1. I'll divide by 2. Cosine x equals 1/2. Okay, and then we're just thinking unit circle. Where does cosine equal 0? Pi over 2 and 3 pi over 2. So there's 2 answers. And then where does cosine equal 1/2? 5 pi over 3. Yeah, pi over 3 and 5 pi over 3. So those will be your answers there. So the best thing to do for these is to do a bunch of practice with them because there are so many different things that can happen with these. So